We have started storage management. Storage management, that means disk management. Disk management, that is what, how many disks you have, and in that disk how many partitions you can create, and how you can create and how you can manage those partitions. So first, when you install the system, you will get the option to create a partitions. That is required, because without creating a partitions, there are some required partitions. There are some system partitions which is required, which is compulsory. So you will not able to install your system without that partitions, because your system is going to install in that. So you have some of them, and you will get two options, just we have seen yesterday: automatic or manual option to create partitioning. So when you select automatic partitioning, it will create the partitioning automatically, and it will create required partitions. Like basically it will create required partitions like system partitions, which is compulsory for the system. And it will create some data partition, so not some, like one data partition that is for home. That is for home, because in home directory you will get all the users home directory, and that means you can get lots of data there. So it will create, in automatic partitioning, it will create a home partition for the home directory, but only if the size of your hard disk is greater than or equal to 50 GB. Otherwise it will not create home, it will create only the system required partition. Manual partitioning, that means you will create your own all the partitions manually, whether it is system partition or data partition. So you will have to create them manually, and that we have seen it when we have done the installation. And these are the default layout. Like if you see the system partitions, and then you have data partitions. Now in a default layout, it will create only the system partitions, that is /boot. This boot directory is for the bootable files. That means all the files which is required to boot the system, these files are in this boot directory, and this directory needs a separate partition. So system partitions, that means it will come under the system partition. So whenever you install the system, it will create this one partition for boot, and the partition for boot will always be number 1, because it is having a bootable files. Then the compulsory partition is /, because everything in your system they come under the /. All the directories in your system will come under /. In Linux system, you will not see partitions, you will see only mount point. That means when you open the system, when you go to my computer, that means if you go to the graphically, in command line you will not see anything, but in graphically, when you go to computer like Windows, so you will not see partitions here. You see only what, these directories, and these directories are the mount points of the partitions. So if you are having any directory here, you are not having any partitions. So partitions are basically mounted on these directories. Now all these directories are under /. That means if you see, if I list /, that means I'm listing my computer, and when you see this, you will see all the directories are inside this, and whatever you create in the system, everything, every file, every directory will go under the /. So this / must need a partition, because it must store the file somewhere. Whatever you create, whether you create graphically or command line, let's say I want to store movies here, so I will right click and click create new folder. So where I'm creating under /. If I'm creating in the system, so if I create like this, mkdir, So wherever I create, it will create under slash. Whether I create directly under slash, or I create in another directory, like suppose in root directory, I can create directly like this, it will still under slash. If I create under media d1, it will be still under slash. If I create it under mnt, it will still be under slash. That means everything in your system will be under slash. So the slash partition is the root of your file system. So all the directories, all the files, whatever you create in your system, they will come under slash, and that slash need a partition. So that is why what it comes under system partitions, and it creates. Then the next system partition is swap. Now swap is what? It is like a we can say it is like a buffer for RAM. It works like a virtual memory in Windows system. In Windows system, you will have this virtual memory or page files. So it is the same thing here in Linux system. It is called swap. It do what? It provides a buffer area for the RAM. Like it works like a RAM, but not like a completely RAM, because RAM is what? It's a fast memory, and it is the part of the hard disk which is not that fast like RAM. So it works like a RAM, not totally, but only for the process which is not running. Like when you run a process, when you run a software, when you run a program, everything will go on to run on RAM. But if the RAM is full and the program is waiting for the execution, so what they do, those type of programs will wait on this swap memory, so that RAM gets free for the program to run. So when your system is running multiple programs, so some of them is cached under the swap memory. It is compulsory. You have to have this, otherwise your system will not work properly. So it will be created automatically. It is considered as a system partition. After that, anything comes under data partition. That is whatever the partition you create for anything, they comes under the data partition. Just like in Windows, we can say it is a D drive. The system partition is your C drive, and the data partition is like your D drive, E drive, where you keep your data, like home, where, or any other directories. Like suppose I want to keep my movies here. So what I will do, I will create a directory for the movie. Now if I create a directory, it will still be under slash. Now what I do, I will create separate partition for the slash this movie directory, so that we can put the data into separate partition. So we can do this at the time of installation, and after installation also we can do this. Now we can have multiple hard disk in our system. So all the systems hard disk, whatever the hard disk we have in our system, they will get a system name. So hard disk, when we have in a system, they will get what? Will get system name. Now what names they get? Now suppose we connect the first hard disk. My first hard disk. So it will get the name, or remember nowadays we are using iSCSI or SATA. iSCSI we use in servers. Normally we use SATA in normal machines. So if it is a SATA hard disk and it is a first disk, so it will get the name of SDA. Now SDA means this is SATA hard disk, so SD and A means it's a first hard disk. Now if you add second hard disk in your system, so it will get name SD because it is still SATA, but it will get now B. So SDB. Then it goes on, like if you add third hard disk, then it will get name SDC. Then it will get SDD, SDE, SDF, and it goes on like this. Like first hard disk will always be SDA, the second hard disk will be SDB, then SDC, SDD, SDE, and goes like that. Now all the hard disk with the system name, it is called device file. Remember I said Linux is a file based operating system, so everything is like a file. So for the hard disk we have a device file for every hard disk you have in our system. That means for every hard disk we have device file in Linux system. Now the device file, that means it consists of the information about the hard disk, which has configuration, info of HDD. We can say driver file, how it is going to be used, and so on. Now these device files located under this device files located under dev directory. Now this dev directory has all the device files, so it has all the other device files also, and this will have all the device files related to the hard disk also. So in this directory we have all the device files located of the device files of hard disk also. So that means what, if you are having a first disk, so the path of HDD will be in system under dev /SDA. This is for first hard disk. Second hard disk will be dev /dev SDB, SDC. So it will always be under dev. Now when we create partitions in this hard disk, remember I am creating the partition in this hard disk. Like suppose I am creating it on the first disk, second disk, or whatever disk. Let's say I am creating it in first disk. first hard disk. So it will be named as it will be named as it will be named as first partition will be named as under dev slash sda will be the hard disk name, and the partition number will be given as 1. Then if you create second partition, then it will be named as dev slash sda 2, then sda 3, sda 4, sda 5, like this. So all these will be numbered as sda 1, sda 2, sda 3, and so on. So it goes like this. So this is what the number of partitions. So whenever you have a hard disk in our system, in Linux system, it gets the system name as SD. SD for SATA hard disk, A is for first, B is for second, C is for third. And when we create a partition in those hard disk, for example, if you create a partition on first disk, so the name is SDA, and the partition number, it goes on like 1, 2, 3, 4, 5, 6, as many as you create. Now we want to check the current partition table. To check current partitions table, that means the partitions which we have created already, because the system is installed. And if it is not installed, then at the time of installation we can create it. But suppose it is already installed, so now I want to check how many partitions I have. So remember, it will not show you directly, it will not show you in graphically also, because it is having a different system. Like it only shows the mount points, it will not show any partitions. Or I can write it here. In Linux system, we cannot see partitions like Windows machines or Windows systems. So in Linux, it shows only mount points, mount point directories. So we can see only mount point directories, we can't see the partitions. So we can see only the directories, on the directories which the partition is mounted. That means we can see only the directories where partitions are mounted. So we can see only the directories where the partitions are mounted. We can't see the partitions directly. Now to check the partitions and to check the partition table, we have to run some command, and the command is fdisk fdisk hyphen l. This command will show you the current partition table. Let's see that. So when I was installing this system, I installed it manually, and I created the partitions manually. I created a partition for boot, I created partition for slash, then I created the partition for swap, then I created the partition for home. So I created 4 partitions here. Now to check, I will give command fdisk hyphen l, l for list. Now this command, this fdisk, this is to manage your partitions. This is the command to manage your partitions. You want to create partition, you want to delete partitions, so this is the command to manage your partitions. Enter. Now what it is showing here, it is showing here the disk name first. Now you can see the disk name is what? It is actually SDA. Now why it is SDA? Because this is SATA hard disk and this is the first hard disk. So it is saying what? SDA. Now this is the device file and it is actually located under dev directory. So it is showing you the disk name with the path that under slash dev, this is the device file of the hard disk, which is SDA. And now from this hard disk, from the file, it is getting the information that is saying what the hard disk size is what? Almost 100 GB and in bytes and in sectors. Now what is the sector? If you go on to the hardware level, so if you see the hard disk, it divided into sectors and tracks. So physically it is a disk, but logically it is divided into sectors and tracks. So from one sector to one track to other track, the area between the 2 tracks and 2 sectors, it is called one sector actually. Now it is more hardware level. So we have total number of sectors available in this hard disk is this, and it is counting the sector as this, like a unit of sector is equal to what? A sector 1 multiplied by 512 byte, and it is actually 512 byte. This is the minimum and maximum size of the sector in our hard disk, and it is saying here that sector size logical and physical is what? 512 bytes. Now what that means? That means input and output size is also minimum and optimal. Optimal is what? 512 byte. That means if you store any data in the hard disk, then it will be stored in a chunk of 512 bytes, not less than 512 byte. That means chunk of 512 bytes. So if suppose you want to store a data which is 2 bytes, still it will get the space of 512 byte, because it is only input and output size is defined as 512 byte. The label for the disk is this DOS. It is a label for the disk. DOS is what the old systems like DOS, diskless operating system. So it was labeled, this hard disk is labeled as DOS. Now why it is labeled as DOS? Because it is using MBR partitioning style. MBR partitioning style. Okay, this is the identifier for the disk. This is the identifier in hexadecimal, because 0x means the number is hexadecimal. Now this is identifier for the system, like system identify the hard disk with this. number. Now what it is showing here is the available partitions in this existing partitions, current partitions in this disk. Now what it is showing here under dev SDA, this is 1. 1 means this is the first partition. Now this is the size of the partition starting from here, and this hard disk is having this number of sectors, and that it is showing here that the first partition is starting from the sector number 2048 and ending on sector number 97 of 976,895. So it is showing actually sector numbers here, that it is starting from which sector and ending on which sector. Now it is not showing the size in MBs or GBs, it is showing the number of sectors here. Now how many sectors are in between this 2048 to this 976,895, and calculating that, with that you can calculate the partition size, or you can calculate by here. It is showing the blocks available in the partition. The first partition is this block, it is having a number of these blocks. Now blocks is actually, if you consider this block, the block is actually byte. So it is actually a byte, and if I say it is a byte, that means it is, we know that the first partition is almost 500 MB, 512 MB, but still it is not showing the size in human readable. Like what we know that the sizes are like MBs, GBs and KBs. It is not showing it in, but it is still showing the size in that block. It can, you can assume it like a byte. Then here it shows the ID and the name of the partition. This is the name of the partition. We can say type of the partition. Now it is saying Linux partition, because we are in Linux system, so it is what normal Linux partition. Now we know by the name, but system knows it by the type, and it knows by the ID. So for the system it is 83, the ID is 83, and that means it is normal Linux partition. Then the next partition is what? Number 2. Number 2 partition is it is starting from here, ending on here, and this is the size of the partition. This is also normal Linux partition. Now how many partitions I said I created? I created partition for boot. I created partition for, suppose this is boot, I created partition for boot, then /root, then swap, and then for home. So I created partitions only 4, but now we are seeing what, 5 partitions. Why it is showing 5 partitions here? And that is because of this extended partition. If you see, these first partitions are 3 partitions are normal Linux partition. This 4th partition is actually extended partition, and in that extended partition we are having this number 5 partition, and it is a swap partition. You can see the type, this is swap partition. Now what is extended partition? So we have done Windows and we know what is it. So what we know is we have two partitioning style. What styles we have? First MBR and then GPT. So we know that we have two partitioning styles, that is what MBR and GPT. This is same in Windows also. It depends on the hard disk. So when we create the partition, so the partitioning style we have to select what is MBR and GPT. Now MBR is what? In MBR, what it support? It support four only four partitions. Now four partitions means what? Four partitions means what? It consists of four primary or three primary and one extended. So it supports only four partitions. Remember, it supports only four partitions. Now in four partitions, it could be all four primaries or three primary and one extended. So extended partition, we can create multiple logical drives. And what? In extended partition, we can create multiple logical drives. So it can only support four partitions. In the four partitions, all the four partition can be a primary partition or three primary and one extended, and in extended we can create multiple logical drives. So basically it supports only four partitions. It supports only four partition. It supports the partition. It supports the hard disk size maximum to 2 TB and many other options we have seen it already, so we know what is the difference between these two. It is actually the old partitioning style, and it is also bootable. Bootable, that means when we install our system, it automatically create MBR, because MBR is bootable. So in Linux it always create MBR when we install. So if you install the operating system in a hard disk, so the hard disk will be created under MBR. It will create under MBR because it is bootable. In other hand, GPT is not bootable, but it can support 128 and all primary partitions. That means we don't need now extended, we don't need now logical drives and all that. It supports larger size of the hard disk also, larger size of the partitions also, larger size of the files also. But the problem is it is not bootable. That means we in Linux till now, like, we can't install the operating system in GPT. So by default when we install the system, it always be in MBR. Now in MBR we know that there is only 4 partitions, and if you want to create more than 4 partitions, then you have to create extended. Otherwise if you create only 4 primaries, then done, you can't create anything else. It will always be 4 partitions. If you are having a free space, then you can't use it. But if you want to create more than 4 partitions, then you have to create extended partition. So in that extended partition you can create logical drives, multiple logical drives, and that way you can create multiple partitions. So that is why when we install the system, it is created under MBR, and that is why we see here, when we check the partitions, we see this extended here. So what it did, it does not show me that it is doing this. I created first boot partition, then I created slash partition, then I created swap partition, then I created home partition. Then what it do actually, in a background it did create 3 primaries, and after that when I create one more partition, so it do what, it created the 4th partition as a extended partition here. Now in this partition, if you see here, it is starting from here, the third one is ended here like 183, so it is starting it from 184, and it is using the whole space here, the whole sectors here. As you can see, this number and this number, this is the total number of sectors, and it is actually using the total number of sectors here. It is using 199 till 199. That means it is using almost, it is using all the sectors here. So in extended partition it uses the all remaining space, and then the 5th partition it creates under that logical. That means you can see here, under this it created the 5th partition. It is starting from 13 to 14, and now still I have some space remaining because it reaches till 14, but we have till 20, so we have some space still remaining. So it shows this. Okay, so I will put it here. So to check the current partition table, we run fdisk command. Now it shows what, that which partition, how many partitions we have. We have partition number 1, 2, 3, 4 and 5. From here we can see that the partition type is, so in this command what it shows the disk information, like the name of the disk, size of the disk, then how many partitions we have in the disk, and the size and type of the partition. And actually it is not showing the size, we can say like it is showing not in a human readable form, but still we can say like it is showing the size of the partition, and also it is showing the type of the partition. So this command do what? This command shows name of the hard disk, then it shows what? It shows number of partitions we have, then it shows type of partitions, and type of partition. So this is what it shows. This command shows all of this, like the name of the disk, and also like size of the hard disk. So name of the hard disk, size of the hard disk, and also shows the number of partitions we have and type of partitions. So we can see that the type of partition is also here. Now the type of partition for us, it is the name Linux, extended, or swap, but for the system it is a ID, like 83 means normal Linux, 5 means extended, 82 means swap. Now our Linux supports lots of many other partitioning is type, like lots of other type of partitions. So it can support 18, we can create lots of other type of partitions also. And one more thing it is showing here is this star. Now this star, and that means what? It is a boot partition. It is a boot partition because you know the number of partition is mounted on slash boot, and this is the boot partition we have. So it shows the boot partition here. So whenever you see the disk, this star, this indicates that this partition is the bootable partition, like your system is booting from this partition. And maybe if you are having multiple disks, so maybe all those disks may not have the installation. So you will see the partition here with the boot star. That means this is the partition where your system is booting currently. Now as this partition, as this command shows what? The name of the hard disk, size of the hard disk, and shows the number of partitions and what is the type we have, but it does not show that where the partitions are mounted and what is the exactly size in human retrieval. So it is not showing that where these partitions are mounted. So for that, to check partitions mount points, that means where those partitions are mounted, if you want to check that, then we will use command mount. Now mount command shows that which partition is mounted on which directory. So it shows the mount points also. Let's see the command line. So now I will run mount command. Now it is showing lots of information here. Now why it is showing lots of information? Because by default it shows this system partitions, the temporary logical partitions also. That temporary logical partitions, that means they are not real partitions, they are logical partitions. For example, you can see here it is temp fs. This is temporary file system, which is also mounted on this system. The type of this is also temp fs. This is also temp fs. This is also temp fs. These are some nfs. These are some different ones. So these are system created temporary file systems. So actually it shows by default temporary system created file systems also. Including temporary created system mount points. Remember, I'm not saying partitions, it is just a mount points. So it also shows the temporary created system mount points, which is not real mount points. Now if we want to check our partitions, so what I will do, now these are also there, like our partitions are also there, but we are not able to find because it is too much there. So what I will do here, I will use the pipe command here, and then I will say I will grab, and I will grab what, SDA, because our hard disk is what, SDA. So I want to see only the partitions which is only the information about SDA, like in the line which consists of SDA. So I will run this to filter the output to show only SDA mount points. SDA means our hard disk. Our hard disk is what? Now whether if your hard disk is SDB or SDC, so whatever. So if you want to see that, then you will make it like that. So now what I will do, with mount I will add grab, and I will grab SDA. And now we can see only the information about SDA. Now what it is showing here, that first dev slash SDA1 is mounted on boot. It is mounted on boot partition. Now it is also showing the type of type of file system. Now what is file system? It shows the file system of XFS. Now we will see what is file system, and also it is showing the default options. Now default options are like what, it is read write option, that means it is writable, the partition is writable. Then these other options are by default added. Whenever we mount any file system, these other options will be always automatically added. We don't do this, but these options always be there. These are default options, we can say. So what it is showing, SDA is mounted on boot, SDA2 is mounted on slash XFS type read write, then SDA3 is mounted on home, same XFS and read write. Now it is not showing 4 and 5. Now 4 it is not showing because the 4 is extended, we can't use extended. Now 5 is also not showing because the 5 is swap. Remember, swap will not mount on any partition, any directory. It's a system file, it's a swap file. So mount the swap partition mounted on swap file. It is a system file, so you can't see it like this. It is not a directory mount point. So it is a different file system, it is a different mount, it is different, it is mounted on system file. So those partitions are not showing here. So what this command shows, so this command shows what? It shows that which partition is mounted on which directory. Then it shows type of file system and default options. So this command shows what? It shows the partitions is mounted on which directory. It also shows that the type of file system we have. Then it also shows that what are the default options. Default options are like what? Read, write and all the other options. So this command shows about the mount points and file system type. Now if you want to see it in detail, that means you want to see the size in GB, MB, GB, and you want to see how many size are used, how many is available, and actually what it is, where it is mounted. So to check mount points and size in human readable, then we use this df command. Now df command, like we can use like this df. Now it shows like this. It shows here temporary system generated mount points also. These are temporary system generated mount points. So it shows that also, but it shows our partitions also, like this one. SDA1 is mounted on /boot. Then it is how many size is total, what is used and what is available and what is in percentage in use. Now again it is not showing in human readable, it is still showing in blocks, like 1k blocks. That is, here it is mentioning that 1k block, that means one block is 1 KB and it is having this number of blocks. So it is still not showing in human readable. So what you do, you will add one option here, H. Now when you add option H, and this H means here human readable. So now you can see what the partition, and it is mounted on which directory. Then it is showing the total size 47 GB, use is 4.4 GB, available is 43 GB, 10% is used. And this is the SDA1, it is showing 573 total, it is used, available and in percent and mounted on boot. And this one is home, 19 GB, mounted on home, 62 MB is used, 19 GB is free, 1% is available, 1% is used. Rest of these are system generated mount points. Then also it is showing here our CD information. Like I have connected the CD. The CD is connected. If you see in graphically, you can see the CD is mounted there. So it shows the information about CD also, that the CD DVD system name is what, SR0, and total size of the DVD is what, this. This is actually the size of the data we have in the DVD, 3.8 GB, and total is used because it is the disk and it is not writable, so it is already used, and no free space, 100% is used, and it is mounted on here. So our DVD is mounted here in run media root and this directory. So actually when we connect the DVD, it shows up in the desktop because it is a graphical, so it shows up here. It's a link. It is not located on the desktop. It is the real location of the disk where it is mounted under run media root, and this is the directory. Now because I logged in as a root, so it is mounted under the root directory here under media, run media. If you logged in as a another user, like if I logged in as a user 1, then it will show up like run media user 1 and then this name of the directory. So this command shows with option H. So this command with option H. So this command shows the mount point, then it shows the size in human readable form. So it shows the size and human readable form, mount point and size in human readable form like GB, MB and KB. Now it is not showing the file system type. Now if you want to see the file system type also, then you can add this option again. To see file system type also, we can add capital T option like this, like df -h and capital T. So it will show the file system type also like this. Now it is showing file system type also. And these are temporary file systems. Tempfs, dev tempfs, tempfs, tempfs. In the CD-DVD has this standard file system, that is ISO 9660. This is the CD-DVD file system. In Windows, if you connect the DVD, it also uses the file system. In Windows, it shows UDF, but in Linux, it shows ISO 9660. It is ISO standard file system for DVD or CD. Now, what is file system? Now, what is file system? File system. Now, what is file system? So file system is what? A file system provides a way of separating the data on the drive into individual pieces, which are the files. It also provides a way to store data about these files, for example, their file names, permissions, and other attributes. So the file system also provides an index, a list of the files on the drive and where they are located on the drive. So the operating system can see what's on the drive in one place rather than combing through the entire drive to find a file. So it provides the way of storing the data and retrieving the data. And our operating system can find the data properly in a proper place. And that is located under the file system. We can say it is like a index of files. So our operating system does not have to find everywhere. It knows that which file is located in which place. So your operating system needs to understand the file system so it can display its content, open files and save files to it. If your operating system doesn't understand the system, you may be able to install a file system driver that provides the supports, or you just can't use that file system with that operating system. So for using the storage device, so whatever the storage device you have, whether you are having a hard disk, flash drive, CD, DVD, any storage device needs a file system, a way of storing data and retrieving data. And that file system must be understood by the operating system. If your operating system does not understand it, then you have to install some other softwares to make that operating system understand the file system. But if it is not, then it is not used. That means you can't use it. Now, the file system which we have in old days, it was FAT. FAT means file allocation table. As the name said, it is a table. It was an old file system which everybody uses, FAT16, then FAT32, but now Windows uses NTFS. If you see in Windows machines, if you go to the Windows hard drive and right click and go to the property, you will see what? The file system as NTFS, new technology file system. Now in Linux, in our operating system, in Linux system, we use ext file systems. This is not NTFS, it is different than NTFS. But it do the same job. But it do it in another way. So what it do, we have actually what? ext file systems. Now what ext file systems are what ext file systems we have? We have actually first ext2. Actually first file system was ext. Then after ext it comes ext2. Now ext2 stands for second extended file system. So in Linux we use this ext file system. Now in all systems we use ext2. It was introduced in 1993, developed by Remicade, and this was developed to overcome the limitation of the original ext file system, as we can say ext1. Then ext2 does not have journaling feature. Now what is journaling feature? I will talk about this. We will talk about this. What is this journaling feature? Now on flash drives like USB drives, ext2 is recommended as it doesn't need to do the overhead of journaling. So ext2, if you are using ext file system in your flash drive, USB drive, then it is recommended to use what? ext2. Otherwise, by default, all the flash drives uses FAT file system. Why they use FAT file system? Because FAT is universally accepted and it is not using journaling. So you can use this FAT file system to connect anywhere in Windows, Linux, or any other devices. Now, maximum individual file size can be from 16 GB to 2 TB. It is the limit of ext2 file system. Overall, ext2 file system size can be from 2 TB to 32 TB. That means it supports only this size. This is the size of individual file, and this is the size of the total disk, we can say 2 TB to 32 TB. Now after that ext2, now we get ext3. It get advanced. Now what we get in ext3 is what? It is also what? ext3 stands for what? Third extended file system. It was introduced in 2001, developed by Stephen Tweedy. Now starting from Linux kernel 2.4.15, and it was used Win kernel 2.4.3. This is the version of kernel was available. Now journaling has a dedicated area in the file system where all changes are tracked. When the system crashed, the possibility of the file system corruption is less because of journaling, and this is the job of journaling. So when we say journaling, then what it do actually, it plays the specific area where it writes and it tracks the changes. For example, like suppose we are writing the file, 1 TB file. We are copying 1 TB file in our hard disk, and these files are going into our hard disk. It is copying. These files are of 1 TB. Now what happened? In the middle of copy, suddenly your system crashes. Maybe you lost the power, or machine shuts down, or whatever. Now what happened if you're not having journaling system? What happened here? When we start the system again, the file was not totally copied. It was break in middle. But in the hard disk, it assumes that it is copied totally, and it shows the full size in hard disk. That means you will see like it is copied total 2 TB, but because it is actually not copied 2 TB, in middle it is break. Now it is break, that means the whole file is not copied. Now when you try to run the copy, when you try to open the files, it will not open because it is not copied properly. It has failed to copy. Then what happened? It is corrupted. Now in the case of journaling, what it do, when it try copying the file, remember when it is copying the file, it is keeping the track of the files, like how many files are copied and how many files are remaining to copy. So in the journaling, it is like a journal where it is writing the changes, like file number 1 copy, file number 2 copy, file number 3 is copying, file number 4 5 is waiting to copy. Now if suppose in that middle, in that process, if your system crashes or power lost, then what? Your system knows that how many files I have already copied, and how many files are being copied, and how many files are to be copied. So it knows the exact location and exact position of the files which is already copied, and it is in the process of copying, or it is remaining copy. So when you restart the system, it will copy. It can start the copy at the same point, and it will not corrupt the file. That is the benefit of journaling. And this has a dedicated area in the file system in ext3 where all the changes are tracked. And when the system crashes, the possibility of file system corruption is less because of journaling. Now maximum individual file size is again still 16 GB to 2 TB, and overall file system can be 2 TB to 32 TB, just like ext2. But ext2 does not have journaling, ext3 has journaling. Now there are 3 types of journaling available in ext3 file system. 1 journal, and 2 ordered, and 3 write back. Now journal means what? Metadata and content are saved in the journal. Metadata is mean of the information about the data, and the content means the actual data. So it will be stored and saved in the journal. Now in ordered form, only metadata is saved in the journal, and metadata are journaled only after writing the content to disk. This is the default, and this one is the default in ext3, that only. So in ordered, only metadata is saved in the journal. So only the metadata is saved, and metadata are journaled only after writing the content to disk. So when the content is written on the disk, then the metadata will be journaled. That means it will saved in the journal, and this is the default one. Then the write back form. In this, only metadata is saved in the journal, and metadata might be journaled either before or after the content is written into the disk. So content may be copied or not copied, or right before it can be stored. The metadata will be stored in the journal. Now you can convert the ext2 file system to ext3 file system directly without backup and restore. Backup and restore, that means you don't lose your data. You can still just convert your ext2 to 3. That means upgrade. It is just like supporting the backward compatibility. So you can convert your ext2 file system to ext3 file system without losing your data, without need of backup and restore. Now what we have is ext4 file system. That ext3 file system was available till by default it was set in RHEL 5. So it was set by default till RHEL 5. When we get RHEL 6, this ext4 is the default file system in RHEL 6. Now ext4 stands for fourth extended file system. It was introduced in 2008, and it is starting from the Linux kernel 2.619. ext4 was available. Now supported huge individual file size and overall file system size. That means maximum individual size will be now 16 GB to 16 TB. It is too much. It is more than 3 and 2. Then overall maximum ext4 file system size is 1 TB, 1 EB, yani that means hexabyte. Hexabyte is equal to 1 hexabyte is equal to 1024 petabyte. In the petabyte, 1 petabyte is equal to 1024 terabyte. EB. So it is too much. It is huge. It supposes huge file system type and file size. And directory content. Directory can contain a maximum of 64,000 subdirectories as opposed to 32,000 in ext3. So in ext3 we can have only say 32,000 of subdirectories. That means in one directory you can create only 32,000 directories, but in this ext4 you can create 64,000 subdirectories. Then you can also mount an existing ext3 file system as ext4 file system without having to upgrade it. That means if you're having a ext3 file system in your hard disk, in your partition, and you want to mount it as a ext4, that you can do. You can do that without changing the file system, without deleting the data. Remember, when you change the file system, it is the chances of losing the data. Now several other new features are introduced in ext4, that is multi-block allocation, delayed allocation, journal checksum, fast FCSK, etc. All you need to know is that these new features have improved the performance and reliability of the file system when compared to ext3. So these all new features only extended the reliability of ext4 file system. So this is basically ext4 is what is basically the more stable file system of Linux till now. Now in ext4 you also have the option of running tuning the journaling feature off. That means if you want, then you can disable the journaling feature also, which you can't do it on ext3. Now, this ext4 file system was the default file system in RHEL6, but now we are using RHEL7. Now in RHEL7, the default file system is what? XFS. Now the XFS file system is an extension of the extent file system, like the extended file system. This is just an extension of this extended file system. XFS is a high performance 64-bit journaling file system. It is what? High performance 64-bit, because now we are having a systems which uses 64 bits. So support of XFS was merged into the Linux kernel in around 2000 and 2009, and Red Hat Enterprise Linux version 5.4 uses of XFS file system. So it was used in Linux 5.4 also. It was there, but now RHEL7 uses XFS as the default file system now. So now it is the default file system in our RHEL 7.0. Now default means when we install our system, this will be the file system for every partition. And as you see here, when we check the data, when we check the partitions, and also we check the file system, we saw it is showing what? XFS by default. Now this XFS is just an extension of the extended file system. Now it is as good as ext4 file system. So now RHEL7 uses XFS as the default file system. Now XFS supports maximum file system size of 8 hexabyte for 64-bit. That is what a new thing here. Now some compression of XFS, some comparison of XFS file system is XFS file system cannot be shrunk by poor performance with deletion of a large file system, a large number of files. So this is what one drawback in XFS. It cannot be shrunk. Poor performance with and it has poor performance with deletion of large number of files. So if you delete the large number of files, it will give you a poor performance. That means it will delete very slow, and it cannot be shrunk also. Then 32-bit systems and 64-bit systems. It supports both 32 and 64-bit systems, and in file size it is 16 terabyte to 16 hexabyte, and file system type it supports 16 terabyte to 18 hexabyte. Now to check the partitions, we know this command. It shows the size, partition name, hard disk name, size, and shows the number of partition and type of partition. Then to check the partition mount points, we can use mount command. This command shows the mount point and also shows what the type of file system also, and it also shows the default options. What are the default options we have? Then to check the mount point and size in human readable, we can use df-h command. It shows the mount point and size in human readable. And if you want to see the file system also with this command, then you will add df-h with capital T. Now to check size of any directory. That means I want to see the size of the directory. I don't want to see the size of the whole file system, whole partition. I just want to see the size of the directory. Then I can use the command du. Now du will also show you not in human readable. Then you can add sh here. So it will show you what the size of single directory. That means for checking the hard disk we use this command. We have the name of hard disk, size of hard disk, number of partition, type of partitions. Then to check the partition mount points with the file system and options, we can use the mount command. It shows the partition is mounted on which directory, with which file system, and also with which default options. Then if you want to see the size used remaining in human readable, then we use this H. And if you want to see the type of file system, also capital T. Now it is showing here like it is SDA2 is mounted on the slash, but under slash we have too many of directories, and I want to see a particular directory size. Like I want to see what is the size of etc directory, what is the size of var directory, what is the size of log directory. So what I can do, I can use du command with -sh option, and then I will mention the name of the directory which I want to check. So it is showing that this directory is using 34 MB. Now it is showing in human readable because we use this option. For example, I want to see what is the size of log directory. So where log, it is 7 MB. I want to see what is the size of where directory. So it is 327 total size of where directory, and in that the log directory has only 7.9 MB. So this du-sh command shows size used by any directory, and also in human readable form. So it shows this size used by the human the directory by the human readable form. Now we have not created any partition. These are already there. These are created when the installation has done, when with the installation. So what it has and what is these default things. Now we know all of these things, and now we can do what? We can create a partition. So now we are ready to create partitions, and now we are going to see that how we can create the partition. Now this we will see next time, that how we can create new partitions and how we can delete those partitions and what we can do with them.